Now we will discuss the discrete time Fourier series, that is DTFS. Now first we will see what are the major differences between a continuous time Fourier series and discrete time Fourier series. Remember, only one or two minor changes are there between this continuous Fourier series and discrete time Fourier series. Remaining all is same only, the property including properties also, right? So what are those major differences? We'll see. The Fourier series representation is infinite series. See, what is this? This is a continuous time Fourier series. So it is infinite series, right? But if it is discrete time Fourier series representation is finite series, right? So when we are getting finite series, so there are no mathematical issues of convergence, right? So that means if any periodic signal, it can be written as the discrete time Fourier series, representation of Fourier series. So, but in this continuous time Fourier series, we should satisfy three Dirichlet conditions, but not here, right? So that is some advantage of discrete time Fourier series. Now the representation of AK. So once we find the Fourier series coefficient, so we have seen that is aperiodic in nature. That means, so if I draw this AK, right? Now it may be some 0 will get something, then something, and so on, right? So it is infinite series, but it is not a periodic signal, right? But the moment it discrete time Fourier series, the representation of AK is periodic in nature, right? How we'll see, right? So these are the two major differences. So continuous time Fourier series infinite in infinite series and aperiodic, and discrete time Fourier series is finite series and it is a periodic, right? Finite series means so up to some suppose 0, 1, 2, 3. So 0 means 0. Suppose it is something like this. Now after suppose this periodic is 3, then it will repeat again something like this, right? So from 0 it is, then so 4. After this it will be repeated 5, 6, 7, and so on. But in this case, so there is no repetition. So it may be continuously increasing or continuously decreasing, etc. Or it may be stopped here, because sometimes for all Fourier coefficient that is 1, 2, the remaining will maybe 0, right? But here it will be repeated. It may be 0 also. It will be repeated in the discrete time Fourier series. Now we'll go to the discrete time Fourier series representation. So again the same condition. If any periodic signal x of n is there, so it should satisfy this condition. X of n should be equal to x of n plus n. So what is n here? It's the smallest integer which the equation holds. So this is n is called fundamental period. Fundamental period. Now once the discrete time signal is a periodic signal, so it can be represented by harmonically related exponential series. So that is sigma, and remember, so this will be for single period, that is n, right? So only we need to summation be only for single period. In the case of continuous time Fourier series, it will become minus infinity to infinity, and the Fourier coefficients AK into e power j k omega naught n. N is the discrete time in nature, right? Discrete in nature. Now what is omega naught? Omega naught is a fundamental frequency which is represented by 2 pi by n. It is called fundamental frequency, or we can say first harmonic also, fundamental frequency, right? Now this is the Fourier series representation of given x of n, which is a periodic. Now how to find the Fourier coefficient? Same Fourier coefficient also we need to summation the up to one time period, that is anyway we know, into that is x of n into e power minus jk omega naught n. So these two are the Fourier series phase, right? So this is the Fourier series coefficients. So AK is called Fourier series coefficients or spectral coefficients, right? Fourier series coefficient. Now both this one anyway we said it's a finite series, right? And this is also finite series and it is a periodic in nature, right? Periodic. So we said this AK is a periodic in nature. That means it should satisfy some condition. That is, this is a very important condition. AK is equal to AK plus n, right? So that means it is periodic in nature. So suppose if I want to find a5, and suppose let n is equal to some 5 is our periodic time period, and if I want to find a1, so it will be a1 plus 5 a6. That means if I know a1, I can find the coefficient of a6 also. Solve this question. The x of n is given, that is sin omega naught n, and this time period is given as n is equal to 5. Now it's very simple. If the sin is there, cos is there, we can easily expand in terms of the exponential. So it will become e power sin theta means e power j theta. So j into omega naught n minus e power minus j omega naught n by 2j. Right? So, but what is omega naught here? Omega naught is equal to 2 pi by n. So what is 2 pi by n? 2 pi by 5. Right? Now how can I represent 1 by 2j into e power j into 2 pi by 5 into n minus 1 by 2j e power minus j into 2 pi by 5 into n. So this is the x of n. Now see, this is the fundamental frequency omega naught itself. So that's like it's a fundamental frequency components, or we can say first harmonic. Now what is the coefficient? So coefficients is equal to, that is 1 into omega naught. So a1 is equal to 1 by 2j, and see this is k equal to minus 1. So a minus 1 is equal to minus 1 by 2j. These two are the Fourier coefficients. And what is n? N is equal to 5. Now if I draw the Fourier series coefficients in a diagram, see the n is equal to 5. So n is equal to 5 means, so the coefficients will be from 0, 1, 2, 3, 4. So 5 number will be, so it will be repeated by these 5, right? So first we will represent this n is equal to k equal to 0. Sorry, k equal to 0. So in terms of k only. Now at k equal to 0 we will get 0, but k equal to 1 we got 1 by 2j, and k equal to minus 1 we got minus 1 by 2j. Now this will be repeated for this n is equal to 5, that is after 5 intervals then will get repeated, right? So this is from minus 1, 0, 1, right? Then 2, then 3. See, minus 1 to 3 is 1, 2, 3, 4, 5. 5 samples are over. Then from 4 onwards it will be repeated. So 4 means we will get minus 1 by 2j. 5, this is 4. 5 means we will get 0. Then 6 means we will get again 1 by 2j, and so on. Similarly here also, right? Minus 2, minus 3 will be 0. From minus 4 it will be repeated like this. So here 1 by 2j, then 0, then minus 1 by 2j, etc. Right? So minus 4, minus 5, minus 6. Right? See, it will be repeated like this. Next we will see the properties of discrete time Fourier series. Right? So almost all the properties are similar to the continuous time Fourier series. So it is a minor change. Now if you see the Fourier coefficients and the periodic signal, x of n and y of n both are periodic with period n. And what is the fundamental frequency? 2 pi by n. But Fourier coefficients also ak and pk for x of n ak, y of n pk with periodic n. So ak and pk are also periodic with period n. That means in discrete time Fourier series, Fourier coefficients as well as the input signals are also the period. Both are periodic signals, right? Now the first property is always linearity. So what is the linearity property? If I take some constant into a into x of n, another constant into y of n, the Fourier coefficients also will be multiplied with the same constant with ak plus b into bk. And remember, the summation of the periodic is periodic in nature. Similarly, summation of Fourier coefficients also will be in periodic in nature. Next one is the time shifting. And what is the time shifting? If suppose if I take some x of n minus n naught, right? Now the Fourier coefficients will be as same as the continuous time Fourier series, that is e power minus j k omega naught n naught into ak, right? So what is n naught? The time shifted version. Now this same also can be written as e power minus jk. In place of omega naught, I can replace with 2 pi by n into n naught into ak, right? So same as like this. So I just replace omega naught is equal to 2 pi by n and everything is same. Now if it is minus, we are getting minus. If it is a plus, we will get plus, right? So here also plus, here also plus. So it may be advanced version, it may be delayed version. So here we will get either plus or minus depending on this notation, right? Next we will see the frequency shifting. So what is the frequency shifting means? E power j some constant j m into omega naught, right? If it is e power j m into omega naught into n, right? The variable n into x of n, right? So the frequency is changing here. Then in the Fourier series coefficient, simply it will become a k minus m, right? Whenever there is a positive, we will get k minus m. This is shifted delayed version. Suppose this is plus means we are getting minus. If it is minus, we will get plus. Remember, right? So opposite in the time shifting, whatever the sign here, we will get the same sign. In the frequency shifting, whatever the sign here, we will get the opposite sign. Remember this one. Next one, conjugate. So what is the conjugate? Suppose if I take x conjugate of n, what is the Fourier coefficient? Same as in the continuous time Fourier series, a minus k conjugate, right? That is the conjugate one. Next we will see the time reversal. So this is time reversal means simple x of minus n. So if I take a reversal of this x of n, here also we will get the reversal, that is a minus k, right? So these are the 5 properties. Next we will see one more property, which is time scaling. So this time scaling only the we get difference in this discrete time Fourier series. So that is the time scaling can be written as like this: x m of n, right? So what is this meaning is x of n by m if n is multiple of n, right? If n is a multiple of m, that is if n is equal to 1m, then mm cancel as x of 1. If n is equal to 2m, so mm will be cancelled. So n should be multiple of m only, otherwise we will get 0, right? If it is not a multiple of m, so I will take as otherwise. Only it is valid when n is a multiple of m, right? So only the difference here we will get in the continuous time Fourier series. No difference in the what you call the Fourier coefficient, but here we will get 1 by m. So whatever the integer, so we are scaling, so that will become 1 by m, right? So what is the reason is, so it is a periodic in nature. So what is the period here? We will get the with period m into n. So 1 by mn will get, so 1 by m of ak. So this is the only difference in from the continuous and discrete time Fourier series. Next, periodic convolution. So it's very same as in the continuous only. So what is the periodic convolution means? If I do convolution in this domain, that is some small r, which is the some periodic, right? Then x of r into y of n minus r. If I do convolution in this discrete domain, then we will get multiplication in the Fourier coefficients with the time period n. So we will get ak into bk, right? Same as in the continuous time Fourier series. Similarly, if I do multiplication in this discrete domain, that is x of n into y of n. So what we will get? The convolution in the Fourier series coefficients. That is sigma. If I take some L is equal to, again with the period only, the time period n. So we will get AL P K minus L, right? So this is the two important properties: periodic convolution and multiplication. When you do convolution in time domain, we will get multiplication in the Fourier coefficients, right? That is with multiplied by the time period. Opposite in the multiplication, that is if time domain multiplication in the Fourier coefficients, will get convolution. Next we will see the one more, that is called first difference. What is the meaning is first difference mean? X of n minus x of n minus 1. In case of continuous time, we have taken the differentiation d by dt of x of t. So the same we will do in the time what you call discrete domain is as first difference. So what is the first difference? We see x of n means we'll get Fourier coefficient of ak. N minus 1 means shifting. So what is the this one? See, if I take x of n, if I take ak common, and this will be 1 minus, see this is a shifted version, so if I'll get, if minus means minus jk omega naught into n naught. N naught is given as 1, so 1 minus e power minus jk omega naught into ak, right? Similarly, what is the running sum? So running sum we can make it as like this, that is sigma k is equal to minus infinity to n x of k. So running summation means, so we are summation this x of k from minus infinity to the n. So whenever it is a summation, so we'll get the opposite of this one. So 1 by 1 minus e power minus jk omega naught into ak. So this is for the differentiation in the continuous time and integration in the continuous time. So we'll get whatever here we'll get in the denominator, right? Next one, this is conjugate symmetry for real signals. So we'll get so many in this one. So we have to assume if x of n is real. So we'll get so many. If x of n is real, what is an? An is equal to, or ak, sorry, ak is equal to a minus k conjugate. Now what is the real part of this? So real part of ak is also equal to real part of a minus k. So this is when x of n is real. Similarly, imaginary part of ak is equal to minus imaginary part of a minus k. That means what is the magnitude of this ak? So mod of ak is equal to mod of a minus k. Similarly, if I take angle of ak, so it will become minus of angle of a minus k. So these are the so if x of n is real, ak is equal to a minus k conjugate, and real of ak and real of minus ak will be same. But imaginary part if I take, so we'll get the what you call minus of imaginary of a minus k. Similarly, magnitude and the angle. Next one, this continuation from this conjugate symmetry only. So real and even signals. So if x of n is real and even, so what is ak? ak is also real and even only. Even. If x of n is real and odd, so ak is a purely imaginary and odd, right? So purely imaginary and if ak is real and even, we'll get ak also real and even. X of n is real and even, ak is also real and even. But x of n is real and odd, we'll get imaginary and odd. Now if I take the even and odd parts of this x of n, so if I take xc of n, that is even part, so we'll get real part of ak, right? So only even means only real part, odd means we'll get only odd part, that is imaginary, j into imaginary of ak. So even part only real part, odd part means we'll get imaginary part into j. So this is about the conjugate symmetry. Next, the final one, we want the Parseval relation. So Parseval's relation for discrete time periodic signal. So Parseval relation, again it is telling the 1 by n sigma, this is we need to make up to 1 period, mod of x of n whole square is equal to, what is this? It's a average power. If I want to find the average power of x of n, right? So what do we need to do? If I know coefficients from one period, so if I take the summation square, then we will get average power, right? So it is difficult sometimes when x of n is somewhat complex, then to find the average power it is difficult. So we will take the help of the Fourier coefficients, right? So what is ak? ak mod of ak square is called average power of kth harmonic component. So sometimes in the exam they may ask what is the average power. The question may ask what is the average power at second harmonic component. So what is the second harmonic component? Once we know second harmonic, then if I take mod of A2 square, then we'll get average power at second harmonic. Similarly, third harmonic, fourth harmonic. If I add all the summation of this average power, that is first harmonic, second harmonic, and so on, then we'll get total average power of x of n. Right? So that is the useful of the Parseval relation. So these are the some properties of the discrete time Fourier series. We have to remember these properties. We may get question from these properties itself also. So remember, from the Fourier series we may get only maximum one question, right? So that's why just remember the properties as the discrete time Fourier series as well as the continuous time Fourier series, and we have to remember the how to find the Fourier series representation, the formula x of n is equal to, right, sigma for a one period ak into e power jk omega naught n, etc. Right? In the next lecture we will solve some problems on this discrete time Fourier series. Right?